Hello students, this is Kumar Physics. So up to now I am not uploading videos. I am sorry because I have a problem in my family. Okay, now we are okay, fine. So from today onwards I am going to upload the videos. So today I am going to start the video from units and measurements. So what is the unit and what is the measurement? So in that unit, so what are the physical quantities? The physical quantities how many types of physical quantities are present? So there are two types of physical quantities are present. So the first one is called the fundamental physical quantities. Okay. Second one is called derived physical quantities. So what are the physical quantities? The physical quantities which are used to measure the mass, length, time. Okay. So the fundamental physical quantities and derived physical quantities. Here, so if you take any object, for example, I am taking this pen. So what is the length of this pen? For example, this is 3 centimeters. So what is 3 centimeters? 3 is the number and centimeter is the unit. Now I am using the paper. So what is the paper shape? It is a rectangle or square. So what is the rectangle area? So for example 4 into 5, 20 centimeter square. So 20 is the number and centimeter square is the unit. Okay. So what is the weight of this paper? So for example this is a 1/4 kg. So 1/4 is the number and kg is the unit. So every time you are going to discuss about one numerical, one unit. That means the physical quantity contains the number as well as unit. So the number and the unit are attached together. That's why the number is inversely proportional to unit. Number is inversely proportional to unit. So that's why you can write like this: number represented by n. Inversely related with the unit. That is nothing but nu is constant. Nu is constant. So what is the number and what is the unit? How many number of units are present? So here, what are the fundamental physical quantities? What are the derived physical quantities? Means the fundamental quantities are nothing but mass, length, time. Mass, length, time initially. Okay. Next, in derived physical quantities, the derived physical quantities which are represented as like velocity, acceleration, length, area, volume, momentum, force, and so on. Okay. So these are the fundamental and derived physical quantities examples. The quantities which are not depend on any other is called the fundamental physical quantities. The quantities which are derived from fundamental physical quantities are called derived physical quantities. So what is the velocity? Velocity is nothing but the distance by time. What is the acceleration? distance by time distance by time square, which is nothing but velocity by time. What is the area? Length into breadth. What is the momentum? Product of mass and velocity. What is the force? Product of mass and acceleration. Okay, so that means every time you are going to use minimum two physical quantities. These two physical quantities are nothing but the fundamental. So those fundamental quantities which are derived from fundamental is said to be derived physical quantities. Okay, understood. So here the number and unit is inverse. So the number is inversely related with the unit. So okay, now how to write the dimensional formula? How to write the dimensional formula for the physical quantities? Okay, so how to write the dimensional formula for physical quantities? So here what is meant by the dimensional formula? So the dimensional formula, which is nothing but here, so from this you observe that the powers of the fundamental physical quantities in derived quantities, the powers are not same. They are changing based on the physical quantity. So now I want to represent an equation. That equation which contains the fundamental quantities and whose powers are changing every time based on the physical quantity. Okay, so for example, see the first one. So I am taking this as first one, nothing but length. So the length is indicated by L. Okay, so what is the unit? Meter or centimeter. So meter power how much? 1. So meter is represented as here. Meter is represented as length. So L power 1. Next, second one, mass is represented as M. kg or gram power 1. That's why it is represented as M power 1. So third one, time. This time is represented as T. This is represented as second or hour, like that, second power 1, T power 1. Okay. Now take the velocity. Take the velocity. As velocity is nothing but displacement by time. Displacement is measured as length. So length by time. So this is formula is displacement by time, which is the unit meter by second. Meter power 1, L power 1, second power 1, and it is moving upside, T power minus 1. Okay, next fifth one, acceleration. Acceleration is nothing but velocity by time. Velocity unit is meter by second, meter by second square. So meter power 1 means L power 1, T power minus 2. Okay, next sixth one. Now take the momentum. Momentum is the product of mass and velocity. Okay, mass unit kg, meter by second, So kg represented as m, meter represented as L, second represented as T. That is the dimensional formula for momentum. Next, force. The force is represented as F, is nothing but ME. Unit of mass is kg meter by second square. Okay. Now kg m power 1, L power 1, T power minus 2. Okay. Next, take pressure. Pressure is nothing but force by area. Force is nothing but MA by area is nothing but length multiplied with breadth. So M L T minus 2 by length and breadth are measured in meters. So L square. So you can write like this: M L minus 1. 1 L gets cancelled, 1 L remains. So M L minus 1 T minus 2. Okay. Next, the stress is nothing but force by area. So stress, pressure have same units. Okay. Next, work or energy, either kinetic energy or potential energy, will have the same units. So work is nothing but force multiplied with the displacement, or kinetic energy is nothing but half mv square. Potential energy formula is mgh. Anyone use m, mass m, g nothing but acceleration due to gravity, L by t square. H is defined as L. So m L square T minus 2. M L square T minus 2. Okay, next 11th one. So 11th one, nothing but if we take a torque, what is meant by torque? Which will produce the rotational effect. The torque is the product of force and perpendicular distance. It is nothing but force into displacement or not. So you will get the same units and dimensions. Torque. Next, moment of inertia. Moment of inertia is represented as I equal to mr square. I equal to mr square. I is nothing but kg meter square. So kg m power 1 meter L power 2. Next, surface tension. Surface tension. That surface tension is represented as D equal to F by L. F is nothing but kg meter by second square. By length is nothing but meter. Meter gets cancelled. M power 1 L power 0 T power minus 2. Next, 14th is nothing but resistance. That resistance according to resistance formula are equal to V by Ohm's law. What is the voltage? W equal to VQ. So V equal to W by Q. That Q is nothing but IT. That Q is nothing but IT. So W is nothing but ml square T minus 2 by IT. We use ml square T minus 2 minus 3 I minus 1. That is V. I is nothing but amperes. So you will get V ml square T minus 3 I minus 2. The resistance. Okay. Next, so next one is the permeability. Mobility represent as mu naught. Next, permittivity. Permittivity represent as epsilon naught. This came in second year, but the units will came in first year. So that's why remember this. The value is 4 pi into 10 power minus 7. 8.85 into 10 power minus 12. So to remember this, you know the formula like that. F equal to mu naught by 4 pi m1 m2 by r square. Here the m is called the pole strength. The unit is ampere meter. So mu naught nothing but Fr square by m square. If m1 and m2 same, so F is nothing but mLT minus 2. R is nothing but distance. The m is nothing but pole strength, units ampere meter. Ampere is current I, meter is L whole square. That is the mu naught. Similarly, in electricity, 1 by 4 pi epsilon naught Q1 Q2 by R square. From that, epsilon naught equal to Q square by R square of Q is nothing but IT, I square T square by L square. F is nothing but mLT minus 2. So if you know the formula, then you can write the dimensional formula. If you know the unit otherwise, then you can write the dimensional formula like that. So what are the physical quantities? First, you know the formula. That formula is converted into the fundamental quantities. So those fundamental quantities which are powers are changed from physical quantity to physical quantity. So here in this matter there are three systems of system of units. So that first one is called the MKS system. Second one is called CGS system. Third one is called FPS system. Fourth one is called SI system. So in MKS system there are three fundamental quantities called mass, meter, kilogram, second, centimeter, gram, second, three fundamental quantities. Foot, pound, second, three fundamental quantities. In these three, the mass, length, time are present only. But here, along with the mass, length, time, the current, the quantity of matter, nothing but mole. Next, radian, steradian. So these are the plane angle. This represents the plane angle. This represents the solid angle. Solid angle. So today, this is the basic how to write the dimensional formula for a physical quantity. So there are 7 fundamental quantities. Here 2 supplementary quantities. Thank you for watching this video. Please subscribe Sri Sai Physics for JEE Mains and NEET. Thank you very much. All the best for your bright future.